Hi, that's Maya. Today we're going to get started with a little bit more of the math side of things. So based on the video that we've watched, you can see that we've got our burning iron, and we talked about the reaction yesterday. Here it's shown, balanced reaction, of course. But there is this mass down here. And that's really the big question we're going to move into. Yes, you can talk about the chemistry of what happens, but how does mass relate back in? Particularly, how do we relate masses of chemical formulas? Just as a brief review of how this all works, remember that the relation between atoms and masses is the mole. And you have a definition of the mole shown here, and specifically those 3 bullet points talking about the relationship between the particle or the amount and the mass. So atom in AMU, moles in grams, and yes, of course, mole does represent a certain number of particles as well. If you want, you can do this on your own, pause the video. Here's some information up top. Solve this question below. As a general rule, I'm going to say let's round our atomic masses to the tenths place. That seems like a reasonable point. And then we'll end up with 2 significant figures in our answer based on the given quantity. But in general, make sure, here's our dimensional analysis. Grams cancel with grams. We're converting from grams to moles. So there it is. Now this does yield the next question where we can calculate the mass of a mole of an element, but how do you calculate the mass of a mole of a compound? And so we have some information here, just some brief vocabulary. The overall umbrella term is molar mass. Molar mass is the mass of a mole. There are several words that mean the same thing as molar mass. They're just a little more specific for the type of matter you can see. You see gram atomic, gram formula, and gram molecular masses. So you'll see these the latter two abbreviated as GFM or GMM. They all really mean the same thing. It's the mass of 1 mole of the compound, and you can kind of see that it relates back to the mass of the compound if you were just counting the atoms. I get this number here for sodium and sodium chloride by adding the masses of sodium and chloride, right? This is 22.999, so that rounds to 23. And then chlorine has the mass of 35.45, so it's like 35.5, and that's where you get your 58. For glucose, there are 6 carbons in every glucose molecule, 12 hydrogens, and 6 oxygens. So you take those masses and you multiply. It'd be 6 times 12 plus 12 times 1 plus 6 times 16, where in parentheses we're putting the mass of 1 atom. And that's how you get the 180.2. I'm, of course, rounding here, but put in that decimal, it gives you a more exact answer. Let's talk about how this all works in a couple practice problems. It is important to make sure you do know how to write your chemical formulas based on a chemical name because, well, the chemical formula affects the molar mass. So here are 2 examples, calcium phosphide and calcium phosphate. If you don't know how to get those formulas, I'll quickly write out some work. Notice that for the phosphate, obviously, we're using table E. Your reference tables are important. And you get a slightly different chemical formula, which means that the molar mass is going to be slightly different. To write out the work for the molar mass, we just need those the subscripts on the bottom. These are all going to be important. For the first example, you're multiplying, obviously, 3 calciums and 2 phosphorus, so you multiply those and then add, you get 182. For the second one, it's important to note that the 2 outside the parentheses does distribute onto both of the elements. So 2 phosphates is 2 phosphorus atoms and 8 oxygens. So when you do your calculation, you get 310.3 grams per mole. You can see how much the difference in the naming, the slight difference in the naming, results in a much larger difference in the molar mass. And then finally, one more thing I just wanted to show. There are a select few chemical compounds that we're going to be introduced to over this unit called hydrates, and they have this dot in the chemical formula. And I know very often the dot means multiply, but in this case, it's a way of saying this is included in the compound, but it's not exactly bonded the way you think it is. And in terms of calculating the molar mass, that dot actually means an add. So we're going to do all the same work. You need to use your reference tables. I've included the relevant atoms here. But we're going to do all our work the same way. Note again, right? So we've got 1 calcium and 2 chlorines, and this 2 in front of the water is a coefficient which does distribute onto everything it follows. So this would be 4 hydrogens and 2 oxygens. So adding all of that up, you get 147.1 grams per mole as the formula mass of this whole compound. So this process isn't too terrible. We're just, as long as you have a chemical formula or you can get one quickly, you can determine the mass of 1 mole of the compound, which is super important for relating masses of one compound to masses of another. Thanks for watching.